Okay, so if you look at the top, you can read what the learning goal is for the first trig notes. It says I can convert an angle from radians to degrees. I can find reference angles. I can convert angles from degrees to radians. I can state trig ratios using SOHCAHTOA. And finally, I can use a square and an equilateral triangle to find trig ratios for 30, 45, and 60 degree angles. Okay, so it's just mixed trig review. The first section is converting from radians to degrees. And it says, remember that pi is equivalent to 180 degrees. We're going to be using that information so that we can substitute 180 degrees in. It says, convert each of the following angle measures to degrees. Always divide 180 by the denominator first, then multiply by the coefficient. So I'll explain to you what that means here in a second. Part A. Everyone agrees that pi radians is just equivalent to 180 degrees, correct? So all we're going to do is substitute that in. Instead of writing pi over 3, I'm going to write 180 over 3. Just subbing that in. 180 divided by 3 gives me how many degrees? 60 degrees. And hopefully by now you have that memorized. That pi over 3 is 60 degrees. If you don't have it memorized, memorize it, because we'll be using that a lot. Pi over 6, same thing. Plug in 180 in place of pi. If I take 180 divided by 6, just shout that out. That would be how many degrees? 30 degrees. And hopefully you have pi over 4 memorized. That would be how many degrees? 45 degrees. Excellent. And then in part D, we're going to do the same thing where I plug in 180 degrees in place of pi. So we have 2 times 180 over 3. That's where this comes into play. Always divide 180 by the denominator first. So I'm going to take 180 and divide that by 3 first. 180 divided by 3 is 60 degrees. By doing that first, it's nice because then I know what the reference angle is right off the bat. Okay, so I always take 180 divided by 3. I know I'm going to be dealing with a 60 degree reference angle. But if I want to know the original angle, then I just have to multiply by that leading coefficient of 2 to get 120 degrees. So it's 120 degrees with a 60 degree reference angle. Any questions about that? If you're someone that resists change, and you're like, well, Mrs. G, I've always converted from radians to degrees by multiplying by 180 over pi. That's fine. If that works for you, and that's what you've always done, you've always converted from radians to degrees by multiplying by 180 over pi, you can still do that. It'll always work. I'm just trying to give you a faster way to approach these problems. All right. So you'll complete the rest of those from homework. The next section is about reference angles. It says reference angles and converting an angle from degrees to radians. A reference angle is an angle between 0 and 90 degrees. A reference angle is not 0 degrees. A reference angle cannot be 90 degrees. It is strictly the numbers between 0 and 90. It's an acute angle. It says the reference angle tells how far away the given angle is from the x-axis. To find a reference angle, you are always finding the angle formed by drawing a perpendicular from the terminal side to the x-axis. Please underline this. To find a reference angle, you always go from the terminal side to the x-axis. I can't tell you how many times I see people drawing a perpendicular from the terminal side to the y-axis. Let me show you what I mean down here. I'm just going to draw in our 4 quadrants. Let's review what a terminal side is. So we start with an initial side. The initial side is always on the positive x-axis, and then we're going to rotate that ray. I rotate that ray, and then all of a sudden it stops. This is your terminal side. It's basically just wherever it ends up. Okay? It's your stopping point. Okay, that's the terminal side of an angle. So let's say that the terminal side is in the first quadrant. What would the reference angle look like? Well, remember the reference angle always goes from the terminal side to the x-axis. That is your reference angle right there. Let's say I'm talking about a terminal side in the second quadrant. I start with this ray, and I rotate it around, and that's where it stops in the second quadrant. My reference angle always goes from the terminal side to the x-axis. That's what the reference angle looks like. In the third quadrant, if this is my terminal side, I go from the terminal side to the x-axis for my reference angle. And last but not least, if my terminal side is in the fourth quadrant, again, I go from the terminal side to the x-axis. That's my reference angle. If I want to construct a triangle, I just need to drop a perpendicular segment from each one of those terminal sides. So in the first quadrant, I go from the terminal side to the x-axis. Drop a perpendicular. There we go. Same thing in the second quadrant, from the terminal side to the x-axis. Same thing in the third quadrant, from the terminal side to the x-axis. And same thing in the fourth quadrant. See how it looks like a bow tie? I call these my bow tie triangles. Whenever we're doing trig, evaluating trig ratios, you should always draw one of these four bow tie triangles. If you are constructing a triangle that goes to the y-axis, you're wrong. Okay? Always, the base of the triangle always has to be on the x-axis. Does that make sense to everyone? Okay. Let's see. Therefore, to find a reference angle, you subtract from a multiple of 180. Okay, so now moving on to this next set of examples, we're going to list the reference angle, then state the original angle in radians. It says to measure a positive angle, you're always going to start at the positive x-axis and go counterclockwise to get the terminal side. Yeah. Yeah. You're good to go. That's another review topic. Let me just go over that really quick, just in case you forgot. Here's my quadrant. To draw a positive angle, you always start with the initial side and go counterclockwise, right? That's a positive angle. If I want a negative angle, I start on the positive x-axis and go down. I go clockwise. That's going to be a negative angle. Okay? We're going to be doing a lot more in this class with positive angles, which is why it specifies in the notes to go counterclockwise. I'll actually make that in blue, since my blue was the counterclockwise. Okay. There we go. Color coordinate. Okay, so I'm just going to start with 150. Here is the terminal side at 150. Right, here's my initial side, and I rotate that ray around, and then I get the terminal side. What is my reference angle? 30 degrees, right? My reference angle is going to go from the terminal side to the x-axis. That is a 30-degree chunk right there. Or what is 30 degrees in radian form? Pi over 6. Does everyone agree that we could say the reference angle is either 30 degrees or pi over 6? Okay, so that's part one. Part two is to rewrite 150 degrees in radian form. How many 30-degree angles do you need to get 150 degrees? 5, right? 5 times 30 is 150. Does everyone agree with that? Or instead of writing that 5 times 30 is 150, I can write 5 times pi over 6. Does everyone agree that 5 times pi over 6 is 150? That's really just like saying 5 times 30. That's an easy way to get it into radian form. You just ask yourself, what times the reference angle equals, we'll say, the original angle. What times the reference angle gives me the original angle? 5 times the reference angle gives me the original angle. Okay, let's do the same thing for 120. So if I'm looking at my picture down here. Here's 120 degrees, the terminal side. Okay, so my reference angle, remember, always goes from the terminal side to the x-axis. What would my reference angle be here? Let's see. Anastasia, what would my reference angle be? 60 degrees. Great. So my reference angle for this problem is 60 degrees. Or how would you put that in radian form? Pi over 3. Excellent. Okay. So now I have to ask myself, what times 60 would give me 120? Cassie, what would you put there? 2, right? So I'd have 2 of those pi over 3 angles. There you go. Quick way to convert into radian form. Again, if you're someone that is stuck in your ways and you think to yourself, well, in the past, oops, let me get rid of that. In the past, to convert from degrees to radians, I always multiplied by pi over 180. That's fine. You can still do it that way. You can still multiply by pi over 180 to convert from degrees to radians, but I just think that this is a quicker method. Any questions? You feel like you can complete that section on your own? All right, the next section, if you flip it over, is SOHCAHTOA. So is for sine, right? Sine is opposite over hypotenuse. Ta is for cosine. Cosine is adjacent over hypotenuse. And TOA is for tangent. That's opposite over adjacent. Right? So SOHCAHTOA helps us remember the trig ratios. Opposite also means y, adjacent means x, and hypotenuse means r for radius. I'm a visual person, so I'm going to show you what that means. I'm going to construct those 4 quadrants again. And I'm constructing it so that this triangle that's pictured is one of my bow tie triangles. Yeah, if I drop a perpendicular from the terminal side to the x-axis, it's one of my bow tie triangles. So horizontal length here would be my x values, right? That's always the horizontal distance. My vertical length would be my y values. And then this hypotenuse right here is my radius. And to better picture the radius, you can imagine that this triangle is inscribed inside a circle. Can everyone visualize that a little bit better now? Okay, your x values, your y values, and then you can see now how this would be the radius of that circle. So using that picture, let's go ahead and rewrite each one of these in terms of opposite, adjacent, and hypotenuse, and also x, y, and r. Okay. So, for example, sine. That would be opposite over hypotenuse. And if I use my picture, here's my reference angle. Opposite of my reference angle would be y, and the hypotenuse would be r. Let's see how I can write sine theta as y over r. Emily, give me cosine. How would you write the ratios for cosine? Oh, sorry, to Emily. Just Emily. Sorry, that was my bad. Go ahead. A over h, right? Adjacent over hypotenuse, which is what in terms of x, y, and r? Great. Adjacent to the reference angle is x, and then r is the hypotenuse. Okay. Other Emily. Go ahead and do tangent for me.
O over A.
Great. Opposite over adjacent. Yep.
Y over X.
And y over x. Excellent. Very good. And then I listed the reciprocals right next to each trig function. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So if I know the ratios for sine, cosine, and tangent, all I have to do is flip those fractions in order to get the rest of them. So, for example, cosecant would be hypotenuse over opposite, which if I flip that fraction would become r over y, etc. You can finish filling that out. Any questions? Okay. Trig ratios for 45 degrees. Says a square can be used to develop the ratios for 45-degree angles. Let each side equal x. find sine theta and tan theta when theta is 45 degrees. So when our angle is 45 degrees. So first of all, I know it's a square. That's important because that means each of these angles is 90 degrees. And it tells us to let each side equal a length of x. And the problem is asking us to find sine of theta, which we know theta is 45 degrees. So it's asking us to find the sine of 45 degrees and also the tangent of 45 degrees. How am I going to get a 45 degree angle using a square? What else do I have to draw in? I heard it. The diagonal, yeah. We're just going to draw in a diagonal, and that's going to split that 90 degree angle into two 45 degree angles. And then at that point, just pick one of them. I'll pick this one. Let's go ahead and use this right triangle. I want to evaluate the sine of 45 degrees. So I know that sine is opposite over hypotenuse. Opposite of 45 degrees is x over, what's that hypotenuse going to be? Anybody remember the ratios for a 45, 45, 90 triangle? Say it loud. Yeah, it's going to be x, x, x radical 2. So this diagonal is x radical 2. Many of you are probably familiar with 1, 1 radical 2. It's still proportional, okay, it's just we're calling x1 in that case. Okay, but since we're looking at the generalized form, this would be x, x, x radical 2. Okay, watch what happens. The x's divide out, right, to give us 1. Anything divided by itself is just 1. And then I have to rationalize. Multiply top and bottom by the square root of 2. So I'm going to end up with square root of 2 over 2. That's my answer. Any questions about that? So you'll go ahead and do tangent of 45 degrees for homework. Last but not least, I'm going to just help you set up this picture. It says trig ratios for 30 degrees and 60 degree angles. Typo. An equilateral triangle is used to find the trig ratios for 30 degree and 60 degree angles. Let each side equal 2x. So we know it's equilateral. Each side is the length of 2x. And if it's equilateral, what does that tell us about each angle? Yes, I heard they're all the same, and even better, I heard they're all 60 degrees. Right? We know angles in a triangle add up to 180. So if I divide 180 evenly between the three angles, that means that each one is 60 degrees. My question says find sine theta and tan theta when theta is 30 degrees. So it asked me to find the sine of 30 degrees and the tangent of 30 degrees. But I don't have a 30 degree angle. It also wants to know the cosine of 60 degrees. How would I have to edit my drawing to get a 30 degree angle? Yeah, what kind of line segment am I going to draw in? What's the name for it? I heard it. Perpendicular bisector, right? Yeah. No, that's right. I had some in my last class say altitude, which isn't wrong. Altitude's correct as well. But even more specifically, it's going to be a perpendicular bisector. I know it's going to bisect this side because it's an equilateral triangle. So it would bisect that bottom side. Okay? So I'll let you fill in the rest for homework. I just wanted to set up the picture with you. That way you knew exactly what I was looking for. Okay. Any questions on the T1 notes? Okay. Moving on to T2 then, it's just more trig review, more mixed review. Okay, so I'm not going to reread all the learning goals. We're still working with reference angles. We just talked about how they're acute angles between 0 and 90 degrees. We measure them by going to the x-axis. Right, we've talked about those things. And in this case, it says ignore the coefficient in the numerator, convert the remainder into degrees, and that is the reference angle. So we're just doing more conversions from radians to degrees. We just did that in T1 notes as well. I'll do a couple more with you. So in example 1, we're going to state the reference angle. Then we're going to rewrite the given angle in degrees. So it told us to ignore the coefficient and just look at the remainder, pi over 6. If I just look at the pi over 6, that will tell me the reference angle. As long as it's a simplified expression, that will tell me the reference angle. So looking at pi over 6, what kind of reference angle am I working with here? 30 degrees. Yep, 180. Remember, you can just plug in 180. 180 divided by 6 is 30 degrees. And I have 5 of those 30-degree angles. So what is the original angle equivalent to in degree form? 150 degrees. Okay. Any questions about that? Okay. Again, in part B, just ignore that leading coefficient. Making sure, you gotta make sure this is simplified. It's nice and simplified already. Okay, so I ignore the leading coefficient and just focus on that pi over 3. Right, so what's my reference angle there? 60 degrees, right? 180 divided by 3. And I have 4 of those 60-degree angles. Okay. So let's see. Math, what would that be?
45. Or down.
Yeah, just what is the original angle and 240. Yeah, 4 times 60 is 240 degrees. Okay, so those are equivalent. Any questions about that section?
Hi there. Welcome back.
Everyone feel confident you can finish that section out? All right, number 2 is converting from degrees to radians. So we're going in the opposite direction. It says every angle can be described in either degree or radian measure. To change from degrees to radians, we're going to find the angle in radians and then figure out what coefficient find the reference angle in radians and then find out what coefficient makes the angle equivalent to the given angle. So again, we did this before, but we're going to do it again. Okay, so 330. Let's think about what quadrant 330 lies in. Christina, I'm going to talk to you. What quadrant would 330 degrees be in? The 4th quadrant, excellent. There's our 330 degrees. So what reference angle am I working with? 30. Which is what in radius form? 5 or 6. Great. So that's step 1, is to find the reference angle. And then step 2 is to figure out what coefficient makes the angle equivalent to the given angle. So Abby, what would you have to multiply 30 by in order to get 330? 11, excellent. 11 times 30 is 330. Or I could say 11 times pi over 6. Oh, okay. Nope, this will work. Okay. 11 times 30, or pi over 6, would be equivalent to 330. So that would be what the original angle is equivalent to. Okay, let's do the same thing for 240. Okay, 240 degrees. Bri, maybe in the 3rd quadrant. Excellent. And what would the reference angle be there? So I'm going from the terminal side to the x-axis. I want to know what this angle is. 60 degrees. Excellent. Okay. And then try what's 60 degrees in radian form? Pi over 3. Very good. Okay. So now, let's see. Isaac, welcome back. What would I multiply 60 by in order to get 240? 6 times what is 24? 4. So 60 times what is 240? 40, right? 6 times 4 is 24, so I just slap a 0 on the end. So I would have 4 times times 60 is 240, right? So we have 4 pi over 3, right? 4 times 60 is 240. Any questions about that? All right, so I'll have you guys just finish that up. Yeah, let's move on to the next section. All right, so section 3 is just labeling the sides. I want to make sure that you guys have the correct labels for 30, 60, 90, and 45, 45, 90 triangles. Some more geometry review. Let's call this angle 30 degrees and this angle 60 degrees. Remember that across from 30 degrees is the short leg. Short leg is across from the little angle. So I'm going to rewrite this in terms of x right now. Okay, so we're going to say that that short leg is a length x. Across from 60 degrees should be the long leg. So that would be your x radical 3. Then across from the right angle would be your hypotenuse. And I call it a hypotenuse because it's got the number 2 in it. Hypotenuse. So that's the ratios in terms of x radical 3 and 2x. If I were to give you a problem like sine of 30 degrees, sine of 30 degrees would be x over 2x. You can see what happens with the x's. What happens? They cancel. And in fact, they'll always cancel and give you a reduced constant as your answer. So does it really matter what x is? No, because if they're going to cancel out anyway, x could be any number. That's why we study similar triangles in geometry, so that you can understand dilations. These angles can produce many, many, many triangles. Okay? As long as the sides are in the same proportion, though, as the 30, 60, 90 triangle, the sine of 30 would always reduce to 1/2. So oftentimes what teachers will do is they'll just pick the easiest value for x that they can think of. What's an easy value for x? 1. Okay? So rather than having to worry about this step every time where you have to cancel out the x's, they'll just call x 1 and rewrite this as 1 radical 3, and 2 times 1. That's where you end up with the 1 radical 3, 2 expression. And you're going to see me use that. I'm not going to use the x radical 3, 2x anymore. I'm always just going to use the 1 radical 3, 2. Same thing goes with 45, 45, 90 triangles. The ratio is x radical 2. But to save me a step, I'm just going to call x 1 and use 1 radical 2 when I'm drawing those pictures. Any questions about that? Okay, so here we go. We're going to just jump ahead to number 5. Number 4 you'll do for homework. But you can see number 4 is just rewriting those trig ratios in terms of x, y, and r again. It's just more practice with that. We've already done that on the T1 notes. So jumping ahead to number 5, this is where we're going to find trig ratios. This is the most missed. These are the most missed types of problems on the trig review quiz. So I want to do a couple with you. If you already have your unit circle memorized and you know all of those points around the unit circle, you do not have to draw me a picture. But I have found that people have more success if they do show some work on the quiz. So here's the process we're going through. 1, draw the triangle in the appropriate quadrant. 2, find the reference angle. 3, label the sides using those special right triangle ratios. And 4, find the specific ratios. Okay. So let's start with sine of 330. Sorry, my one froze. One more. Here we go. Okay, sine of 330. I'm going to first start by drawing a triangle in the appropriate quadrant. That would be the fourth quadrant. Right? There's my terminal side. And in order to construct the triangle, remember we go from the terminal side to the what? X-axis, right? Drop a perpendicular from the terminal side to the x-axis. My reference angle works the same way. My reference angle, I go from the terminal side to the x-axis. That's my reference angle right there in blue. Okay. Step 2, after we've drawn the triangle, is to find the reference angle. So if this is 330 degrees from here to here, what chunk is missing? 30, right? We need another 30 degrees to complete that revolution. So this must be a 30-degree reference angle. Once we find the reference angle, now we're going to label the sides using the proper ratios. So across from the 30 degrees is the short leg. We'll call that 1. Across from 60 degrees is the long leg, radical 3. And the hypotenuse is 2. That's step 3, label the sides. Now we can find the specific ratios. So I'm finding sine of 330. Remember, sine is opposite over hypotenuse. So in order to evaluate sine of 330, we're going to use this reference angle, sine of 30 degrees. And opposite of that would be 1. And the hypotenuse would be 2. That's what the sine of 30 degrees is. The only thing is we have to keep in mind that this is in the fourth quadrant. We have to keep in mind the location. See how we're going to the right radical 3, but down 1? That orientation matters. So I have to remember, since I'm going down 1, put a negative in front of the 1. And so in my final answer, that would become a negative ratio. It's all got to do with the fact that it's in the fourth quadrant. Does anybody remember the phrase that helps us remember what's positive in each quadrant? Yeah, you got it. All students take calculus. All students take calculus. So what is positive in the fourth quadrant? Cosine. And what else? Secant, the reciprocal of cosine. Right? If cosine and secant are the only two ratios that are positive, then sine must be negative in the fourth quadrant. I always use that as a check. Make sure that I didn't forget to label my triangle with a negative somewhere. By the way, does everyone agree 330 degrees is an obtuse angle? Do we use trig with obtuse triangles? No. And so here, in order to use trig, you need a right triangle. That's why we're constructing a right triangle and using the reference angle to help us evaluate this trig ratio. Okay, let's just do one more. Tangent of 300. I'm going to first draw my triangle. So 300 degrees has us land again in the fourth quadrant. I drop a perpendicular from the terminal side to the x-axis. Right? And my reference angle also goes from the terminal side to the x-axis. So that blue is my reference angle. If this is 300 degrees, what would my reference angle be? Alice, what would my reference angle be? 60. Yep, 60 degrees would complete that revolution. So that's step 1. Step 2, I lied. Step 1 is to draw the triangle. Step 2 is to find the reference angle. So now we're on step 3, label the sides. Across from 60 is my long leg. Across from 30 is my short leg. And the hypotenuse is 2. Don't forget, based on the orientation, I'm going to make this a negative radical 3 just because we're going down. So now when I'm finding tangent of 300 degrees, I'm using that reference angle to help me. Tangent of 60 degrees. And I know tangent is opposite over adjacent. Opposite over adjacent would be radical 3 over 1. But just because of the orientation, the fact that it's in the fourth quadrant, that's what makes it negative. Okay. So my answer would end up being negative square root of 3. Any questions about that? Again, if you have your unit circle memorized, you don't have to draw me the picture. It's just a nice way to get some partial credit if you get the answer wrong. All right, last thing I'm going to go over today is for quadrantal angles, 0, pi over 2, pi, 3 pi over 2, etc. They don't have reference angles. That's the thing about quadrantal angles. Anytime it lands on an axis, it's not going to have a reference angle. So here if I'm looking at cosine of 3 pi over 2, remember pi over 2 is 90 degrees and I've got 3 of them. That puts me down here at 270. If this is the terminal side, and I'm trying to construct a triangle, normally to construct a triangle, I go from the terminal side to the x-axis. But see how that doesn't make a triangle? So I need another method. Whenever I'm working with quadrantal angles, I always pick a point on the unit circle. So I'm just going to write point. And I rewrite the trig ratio in terms of x, y, and r. So that's what method we're going to use. The points on the unit circle are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And because we're working with 3 pi over 2, I'm going to be using 0, negative 1, since that's where the terminal side is. What is cosine in terms of x, y, and r? What is cosine in terms of x, y, and r? X over r, right? Adjacent is x, and the hypotenuse is r. Plugging in what I know, my x value is 0. And what's the radius of this unit circle? How do I get from the origin to the point 0, negative 1? What's that distance? It's 1, right? And because we're talking about a radius, it's always positive. The radius is always, always positive. So we end up simplifying to just 0 there. Again, if you know on a unit circle that your x values are your cosine values, the y values are your sine values, and tangent is y over x, you can use that too. You could say, what's the cosine of 3 pi over 2? Well, as long as I'm looking at a unit circle, the x value at 3 pi over 2 is 0. Okay. Any questions? So you're just completing the rest of that trig packet for homework. If you need anything from me, come see me tomorrow morning or after school today. But that's it. That's all I got for you.